Hi, Honors Algebra 2 Trig. Welcome to section 11.3 on ellipses. So an ellipse is the collection of all points in a plane such that the sum of the distance from the two fixed points called the foci is a constant. V1 and V2, as labeled in this picture, are the vertices. So when this equation is centered at the origin, we use these two equations, x squared over a squared plus y squared over b squared equals 1. And when it is centered at the origin and it is vertically stretched, it's the same equation, but notice b squared and a squared have swapped, okay? So we're going to talk through up here what all of these things are. The major axis, minor axis, focal length, vertices, and covertices. Then we're going to label these guys afterwards. So here we go. Let me talk through it. This one's kind of floating in space, right? So we can see the center is where the two axes cross at a 90-degree angle. The foci are actually used to define the shape. And if you wanted to create kind of an ellipse drawer tool of your own, you could take a piece of string attached to two push pins and use that to see that anywhere I'd be able to draw with that pencil would be a point on the ellipse. So coming from these 2 points, this distance that I've just drawn is the same as this distance right here. Even if I went from this push pin out to my vertice and then back to the other focus, that length of string is also the exact same size. If you wanted to, you can actually think of a circle as an ellipse with the two foci landing exactly at the center. The distance out and back, the radius, is the same in every direction. And the equation, if you think about it, is really similar to a circle, right? We've got the x squared plus y squared. The difference is now, instead of equaling our radius squared, we have the a and the b values underneath. We use a and b to identify the major and minor axis. The major axis is longer, the minor axis is shorter. The vertices are on the major axis. The co-vertices are on the minor axis. And the two formulas that you see below, A is always representing the major axis. When the longer A value is with x squared, it goes horizontally from left to right, stretched further. When the A value is with y squared, it goes vertically stretched up and down. And one more thing that's not labeled in this picture, so I'm going to add it. These 2 points from top to bottom are called the co-vertices. The vertices are on the major axis, co-vertices on the minor. Okay, so let me label some things in this picture for you. Let's pretend that this coordinate grid lands right here with our center at 0, 0. In this picture, this vertex lands at the point a, 0. That a value defining how far out the, if you will, radius stretches to the left and to the right. So this is negative a, 0. Up here we have 0, b. And down here we have 0, negative b. The foci are not in this picture, but they will be somewhere on the inside of the ellipse. The focal distance being the distance from the center to a focus in either direction. Similarly, in a vertical ellipse, it's the exact same idea, but your A and your B values have switched. So now, since this one travels further up and down than it travels left and right, we would say that our vertices are 0, A, where the Y value has the A. And this one is 0, negative a. And then our co-vertices are b, 0 and negative b, 0. And this time, the foci land on the major axis. So instead of going left and right, my foci travel up and down. Over here, left and right because it's horizontal. On the other one, up and down because it's vertical. Okay, pop quiz, or actually memory test. we just talked a lot about ellipses. Take a minute and see if you can fill in, not the focal length, we haven't talked about that yet, but all of this information between those two bars. On your own, pause the video, take a look, see if you can write your definition in your words. What does that all mean? And then when you're done, you can come back and join me and check how you did. Okay, so the major axis, this is the one that is longer, and it always will have a length of 2a. The minor axis is shorter, and the length equals 2b. The focal length is the distance from the center to a focus. And by the way, the plural of focus is not focuses, it is foci. That's how we pronounce that. And the vertices are the endpoints of the major axis. And the co-vertices are the endpoints of the minor axis. And then lastly, the foci of the ellipse always lie on the major or longer axis. Okay, one last bit of information. The focal length, which is the distance from the center to a focus, is found using the equation c squared equals a squared minus b squared, where c is the focal length. So if you want to know exactly how far away the focus is from the center, you use that little equation and find c. All right, let's try some. So we're going to graph each of the following ellipses, identify the length and endpoints of the major and minor axes, the coordinates of the foci, the vertices, and the co-vertices. Depending on what your teacher asks you, you may or may not have to include all or some or parts of any of these different parts of the ellipse. So let's practice all of it. First, is this vertical or horizontal? Where's the bigger number? I see that I have a larger value underneath y, so that tells me that this is a vertical up and down shaped ellipse. That means that my a value is going to be the square root of 16, or 4, and my b value is the square root of 9, or 3. I can only use that technique, take the square root of the denominator, if I have the number 1 on the right-hand side. If I don't, I have to do some work. These are centered at 0, 0, so I know that I'm starting at 0, 0, and this part's great. As a student, I never memorized which one was A and which one was B. I just always remembered that the x's go with x and the y's go with y. So the square root of 9 is 3. It was under the x. I go left and right 3 units. The square root of 16 is 4. I go up and down 4 units. And then I remembered, oh yeah, the major axis is the uppy downy one. So the focus is going to be somewhere over here on the major axis. I don't know where. I can find it though. We have the tools. My ellipse is a little lumpy. I'm going to fix it. Sorry, I'm being picky. Okay. Oh, see, it's still lumpy. Oh, goodness. All right, that's fine. All right, so the major axis, we are supposed to say how, like, the length of the major axis. So the major axis was the up and down along the y, and it went up 4 and down 4, and it had a length of 8. The minor axis had a length of 6. The vertices are at the ends of the major axis, so they were located at 0, comma, and I'll let you do plus or minus 4. There's 2 of them, one up and one down. The co-vertices went left and right, so that's the x values, positive or negative 3, 0. All right, now we're going to have to do some work for the foci. So for the foci, that little equation was c squared equals a squared minus b squared. C squared equals a squared minus b squared. So I'm taking the a squared and b squared from the denominators, and c squared equals 16 minus 9. So c squared equals 7, and c is the square root of 7. Now, I don't know exactly what that is, but I also don't need to. I know that the square root of 7 is less than the square root of 9, which is 3, and more than the square root of the square root of 4, which is 2. So it's somewhere in between 2 and 3 units away. So I don't have to be super precise as long as I get it in between the proper two whole numbers. Those 2 points are my foci. And then when I write them down, since they went up and down and they're on that major axis, it's 0 plus or minus square root of 7. All right. This next one is not set up equal to 1. So I can't just start looking at denominators because there aren't any. I need to get this set up properly before I can get there. So to do that, I'm going to divide everything by 4. And I will rewrite my equation to be x squared divided by 4 plus y squared. 4 over 4 cancels out and we just get 1. But I really want to have a denominator so that it fits into my formula. So I write it as over 1 because now I can use that as my a squared or b squared value depending on what the other one is. In this case, since x has the larger value, it's a horizontal ellipse, lefty-righty. And my a value is 2. My b value, the square root of 1, is 1. So I go left 2, right 2, up 1, down 1, circle it up. If I'm going to find my foci, I use my c squared equals a squared minus b squared. So c squared equals 4 minus 1, and c is the square root of 3. The square root of 3 is more than 1 and less than 2. So here and here. Oh, my 3 disappeared. So my major axis has a length of 4. My minor axis has a length of 2. My vertices this time go left and right, so they're at positive or negative 2, 0. And my co-vertices go up and down at 0, positive or negative 1. The foci also go left and right, so these are at positive or negative square root of 3, 0. Awesome. Okay, now let's talk about when they're not centered at 0, 0. This is super similar to a circle. When it wasn't centered at the origin, we have our x minus h and our y minus k. Once you orient your center, pretend like you're at an origin and everything else is identical. Okay, so first one, we have x minus 2 squared over 4, y plus 3 squared over 1 equals 1. So this is going to be really similar to this one, right? Over 4 over 1. The only difference is it's going to be centered at the point 2, negative 3. My a value is 2. My b value is 1. We already did the work up above. My c value is the square root of 3. But we could work through it if we needed to, right? C squared equals a squared minus b squared. And I think I'm ready to graph. All right, so here's 2, negative 3 is my center. My x values tell me to move left and right 2 units. Those are going to be my vertices, and I'm going to actually count them out on the grid. So like on the grid, I can see that the first vertex is at 0, -3, and the second vertex is at 4, -3. Can't do the plus or minus thing anymore. Sorry, kids. Now the y values go up and down. So up and down. So my co-vertices are located at 2, -2 and 2, -5. Wait, did I do that right? 2, 3, 4, 2, -4. Sorry, can't count. It's late at night. I'm trying to do this before I go to bed. All right, did I do all the stuff? I labeled the center. I labeled 4 points, my vertices and co-vertices. They count. And now I need to do my foci. Okay, so for my foci, this is where it gets a little funky. You take the center and you add and subtract the C value. And if it's a radical, that's fine. So my foci are located at the point. I'm changing my x values. So it's going to go left and right to add that square root of 3. So I'm starting with my x value of 2 plus or minus the square root of 3. And the y value stays the same as the center. So comma, -3. And now I'm going to connect my co-vertices and vertices. And I've got a cute little baby ellipse. Okay. Now would be a great time to pause the video and try one on your own. You should have all the skills for this guy. Find your center and subtract all the stuff you got to do. Figure it out. So pause, give it a try, and when you're ready, come back. Okay, hopefully you tried that. So welcome back. This time my center is located at 0, -1. I'm getting that from my h and my k values. My a value right here under my y is 5. My b value under my x is 9. Since the y's have the larger a value, this is a vertical. It's going to be up and down. So I'm going to start by finding my vertices and co-vertices, finding them off on the graph. So here's 0, -1. My x's go left 3 and right 3, and those are my co-vertices this time. If you find it in a different order, that's fine. Just make sure you label it properly. So my co-vertices go -3, -1. And my other co-vertice is +3, -1. And then my vertices go up and down, so I go up and down 5 units. So this is 0, 1, 2, 3, 4. So my vertices are located at 0, 4, and then down 5 units. 1, 2, 3, 4, 5. So 0, -6. You can draw the ellipse before you have your foci, if you want to. This one I can't cheat. I actually have to find my foci, my focal length. So I know that c squared equals 25 minus 9. Another handy thing to remember for c squared, you always want it to be positive. So c squared is always going to be a positive number. So you're always doing the big one minus the little one. So 25 minus 9 is 16. Hey, now that came out nice. So my C value equals 4. So now I'm going to go up 4 and down 4 because that's my major axis. And I will say that my foci are located at 0, 3 and 0, -5. Great. All right. Everybody's favorite. Now we have to complete the square. Okay, so we're going to rewrite the equation to standard ellipse form. This is general form. When you see a big long list with x squared, y squared, x's, numbers all over the place, it shows up all the time. This time we're going to turn it into an ellipse. Okay, so we have to do some organization and then we'll be able to draw our graph. First step, I'm grouping all my x's together. So 49x squared minus 196x plus 9y squared plus 72y equals, I'm moving 101 to the other side. And I didn't leave any spaces yet because I have one more step to do before I can actually do the completing the square part. So the next thing I'm going to do is factor out that 49, right? So I want to factor out that 149. So the 49. So 49 comes out in front, and I have left over x squared, and then 196 divided by 49 is 4x. And then I'm going to leave a space so I'll be able to complete my square. Okay, and then I'm going to color code this a little bit. Let's make all my y values. Let's do these guys in blue. Okay, so now for the y guys, I'm going to do this. I have to factor out my 9. So 9y squared plus 72 divided by 9 is 8y. Leave a space for the completing of your square. And then the whole thing, the whole setup equals 101. And I'm going to have to add some stuff over there, so I might shrink this and move it around a little. Let's see. Give myself a little space. Okay, so back to the x's. We're going to complete the square. In order to complete the square, we do 4 divided by 2, which is 2. 2 squared is 4. And we add that. But we're not just adding 4. We're adding 4 times 49. And if we add it on the left, 4 times 49, which is 196, also needs to get added on the right. Let's do the blue ones. So for the y values, 8 divided by 2 is 4. 4 squared is 16. We're adding 9 times 16. If we do it on the left, we have to do it on the right. So this part right here was 16 times 9, and that's why we're adding 144. We're keeping our equation balanced. Okay. So for the x values, we have 49x minus 2 squared. For the y values, we have 9y plus 4 squared. And then over there on the right-hand side, I add up 101 plus 196 plus 144. And I end up with 441. Okay, looking a little messy, but we're going to be okay. We need to get this set equal to 1 in order to be able to do anything with it. So we're going to divide both sides by 441. And we need to reduce the fraction. 441 divided by 49 equals 9. So we actually, on this part, have x minus 2 squared over 9. On the y values, we have 9 over 441, which reduces to y plus 4 squared over 49. And the whole thing equals 1. So now we have it in our standard ellipse form, which means it's going to be so much easier for us to graph. Okay, we have to find the center, foci, major, minor axis, sketch a graph. Here we go. So my center is located at 2, 4. And I like to label my stuff off to the side. So center, 2, -4. With the x values, the denominator of 9 tells us that we move left and right 3 units. This is smaller than what's with the y values. So these are our co-vertices. Remember, the vertices are on the major axis. The minor axis is the shorter one. So the co-vertices are located at the points -1, -4, and 5, -4. And while I'm here, I'm going to write down the minor axis, which has a length of 6. Okay, now I'm going to do the major axis. The square root of 49 is 7, so I go up and down 7 units. So 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. A little off the grid, that's okay. So my vertices are located at the points 2, 3 and 2, what's that, 4, 5, 6, 11, negative 11. And my major axis has a length of 7 times 2, or 14. I have enough information to draw the outline of my ellipse, but the one last thing that they want me to do is to find the foci. So I'm going to come over to the right where I have some more space. And remember, the foci are at c squared equals a squared minus b squared, major minus minor. For those values. So it's going to be 49 minus 9. I just took the two denominators here and I subtract them. So my c squared equals 40. And c is the square root of 40, which is 2 root 10. When I go back to the square root of 40, the square root of 40 is less than the square root of 49 and more than the square root of 36, which means it's in between 6 and 7 units. So I counted off 1, 2, 3, 4, 5, 6, which means my foci land here. Now I do need to have coordinate points for those. So for my foci, I am adding and subtracting to the y values of the center. So that means that I have my x value is the same as the center. Here's my center over here, 2, negative 4. So 2, negative 4, plus or minus 2 root 10. All right. Last example for today. We are going to use the given information to come up with the equation, right? So working backwards. Mandatory, you have to draw a picture. Drawing the picture helps you see where the major and minor axes are, understand where the focus is, and then you're going to plug in all the little bits to the equations you have. Okay? It doesn't have to be a fabulous sketch, but you just have to be able to have enough information to see what's going on and understand it. Okay, so I'm seeing 10, 1, so I want to make sure I have enough space to get there. Okay, so 1, 2, 3, 4, 1 is my center. 5, 6, 7, 8, 9, 10, 1 is my vertex. Remember, it goes around my center. Oh, what a terrible sketch. Good enough, it's going to work. I don't know how far up and down it goes, but I could measure from here to here to figure out my major axis. Okay, it was really, really terrible. I'm going to fix it a little. There we go. That's better. And then I don't know my minor axis, but since I do know my foci, I know one focus, I can use my focal distance, that C value, to find the B value. So here's my focus at 0, 1. Okay. So if my center right here is at 4, 1, and my vertex over here is at 10, 1, then my A value is the distance between those 2 points, which is 6 units. That means that this vertex over here also travels 6 units. So from positive 4 all the way over here, that's located at the point -2, 1. Because that distance is supposed to be 6 units. My focal distance, I'm going to switch colors for us to get to my focus here in green. So this distance from the center goes from 4 to the point 0, 1. Oh goodness, I put it in the wrong spot. Let me correct that. So for 0, 1 is my focus. That has a focal distance, or a C value, of 4. It's okay that it traveled in the opposite direction from the vertex they gave us. As long as I have the a and c values, I can do this next bit, which says that c squared equals a squared minus b squared. So I just plug it in. 16 equals 36 minus b squared. I get to find b, no problem. All right, subtract 36 from both sides. And then negative 20 equals negative b squared, and b squared equals 20. And I'm going to stop you right here because they ask for the equation of an ellipse. Okay? We know that it's a horizontal ellipse. The equation for a horizontal ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. To find the equation, I don't care what b is. I care what b squared is. Okay, so let's look at all the bits, make sure we have all the pieces. We had our center at 4, 1, so this is our h and our k. We found our a value counting it out on the picture. We knew our c value, which helped us find our b squared, so I think I have everything I need to plug in. So I have x minus 4 squared over a squared, which is 36, plus y minus k, so y minus 1 squared, over b squared, which was 20, equals 1. One more example like this one. So challenge, pause the camera, pause the video, take a look at it on your own, see if you can figure this one out without me. When you're ready, come back, and then I'll show you if you did it correctly. Okay, so 1, 5 is a focus, and 1, negative 1 is the other focus. Foci 1, foci 2. Wait, focus 1, focus 2. And the length of the major axis is 10. That means that the a value, if 2a equals 10, then the a value is 5. And I know that the foci are equal distance from the center, so I can actually figure out where the center is if I can find the midpoint of the two foci. So the midpoint between those two, it's going to be 1 plus 1 over 2, 5 minus 1 over 2, which is located at 1, 2. Or, you could count it out. And that is our center. Now, from my center, I can count up and down 5 units to get to my major axis endpoints, which are my vertices. So up 3, 4, 5. That point is 1, stand by, 1, 7. And then down 1, 2, 3, 4, 5. This one is located at 1, negative 3. So those are my vertices, and this is my ellipse. So I have my a value, I have my center. The other things that I need my b value. So I'm going to have to go back again and use that c squared equals a squared minus b squared bit. So my c value is my focal length, which I can count off in the picture is 3 units. I went 3 up and 3 down from that center. So 3 squared equals a 5 squared minus b squared. So 9 equals 25 minus b squared. Subtract 25 from both sides. So negative 16 equals negative b squared, and b squared equals 16. Again, I could do some more work and tell you that b is 4, but at the end of the day, I just need b squared to plug in. Okay, last part. It's a vertical major axis. If the major axis is vertical, then the larger value goes under y, right? So I think I'm ready. Okay, so x minus h, x minus 1 squared over b squared, 16, plus y minus k, y minus 2 squared over a squared, 25, equals 1. All right, try your homework. Good luck and enjoy the day off.